possible. So that's 3 items. I'm arranging all 3. What am I implying here? What if I don't want to arrange all 3? What if I only want to arrange 2 of these? Then what? Okay, well, let's kind of take off of yesterday's example. What were my 3 symbols? I had a star, a square, and a circle, right? Okay, I only want to arrange 2 of these, not all 3. What choices do I have? Pictorially, I could choose that one. So right off the bat, like if this is flavors of ice cream, how many choices would you have? 3, yeah, right? So you got 3 choices for that first one. But once you have that one, then how many choices do I have? 2, yeah. So I could have that. That's a choice. I could also pick the star and then have the alternative second choice, circle. All right. Now the first one, I still have 3 choices, but I've already chosen that one. Can't choose it again, okay, because there's no repeating yet. So I'm going to have that, and then, well, I could choose the star second. I could choose the circle second. Okay, be systematic. What one haven't I chosen first? Yeah, my third choice for the first one. And then I have 2 choices for the second one. How many total options or arrangements do I have here? Yeah, it's the same answer. That's not always going to work. Okay, this is still equal to 6. Okay, but I just arranged 2 of those 3 items. Okay, there's a formula for that, but let's look at another example first. How many 2-letter arrangements, okay, I'm not going to use the word words because if 2 letters don't make any sense, we don't usually call it a word per se. So that says I got a 4-letter word. How many different 2-letter arrangements can I have from there? Anyone want to take a guess? Nice medium-sized number? No? All right. Let's do it. Physically, visually, okay, good guess. Let's find out. Let's see what happens, okay? I'm going to start with P. I got how many choices for my first letter? 4 choices, okay? I'm going to start with P and then, well, let's pick I. And then I'm going to start with P and then I'm not going to pick I. How many choices do I have for my second letter? Yeah. Any ideas how many I should have here? But total? My last choice, if it starts with P, is G. Okay? That's everything that starts with P. I can't choose the same letter twice. There's no repeating here yet. Okay? Then, well, be systematic. Start with the second letter. And then I could choose P. I could choose N. I could choose G. And start with the third. I could choose a P, I could choose I, or G. How many now? Anyone see it? I got 3, 6, 9. That's the only letter I haven't chosen first. G. And then I could have P, could have I, and I could have n. Any other arrangements, or is that it? How many is that? 12, right? So again, like I said, I had 4 choices for my first letter, and I had 3 choices for my second. Okay? And that's it. I didn't choose a third. I can only have 2 letter arrangements. So 4 times 3 is 12. Okay, there's a little formula for this. Anyone see what it might be? Like, I want factorial notation here for 12, but how do I do it? This, if it's factorial, I have to get rid of something on the bottom, right? What do I have to cancel out from the top? I don't have a 2 and I don't have a 1. How do I write that in factorial? 2 times 1. I know it's first block, but come on, you did this yesterday, didn't you? How do I write that in factorial notation? Yeah, okay. I want to cancel this on the top. That's not here. So what do I want to put on the bottom? Cancel that. Is that still 12? Yeah, right? Okay, that's 4 times 3 times 2 times 1, and on the bottom I got 2 times 1. I don't want those. I want this to equal 12. So if I want to write 12 in factorial notation, one of the ways I can do that, if I have to start with 4 factorial on the top, is 4 factorial over 2 factorial. Okay? So that's, you might think to yourself, well, there's where I get the 4 from. I have 4 choices, and I choose 2 of them. Okay, so you might be guessing it's just 4 over 2. It's actually a little more complicated than that. This is what we've been doing. That's what that says. If I have n objects and I want to arrange r of them, don't ask me why they chose n and r, but that's what they all do. Okay, this is n factorial over n minus r factorial. So this is arranging r objects from a possible n objects, okay? Because we're not going to always arrange. If you got 8 things, that doesn't mean you're going to arrange 8 of them. You might only arrange 4 of them, maybe 6 of them. Okay, so that's like a bit of a formula. Okay, so putting this in this, if that's what we're given, because we don't want to do a picture every time, because as you see, some questions have 5,000 options. We'd be there for a long time, and there's no way you'd get them all, okay? No brain could keep that straight, right? So this, I would have 4 things, that's n, over 4 minus, I want to arrange 2 of them. Okay, well that does become 4 factorial over 2 factorial. Okay, this one, I have 3 items, I want to arrange 2 of them. So that is n factorial, that's the number of objects I have, over 3 minus 2 factorial. I'm going to arrange 2 of them, okay? So that's n, p stands for permutations, 2, right? I'm going to arrange 2 of 3 items. N factorial over n minus r factorial. And what's 3 minus 2? 3 minus 2 is 1 factorial, which is just 1, which is just 3 factorial. So again, I have 3 times 2 times 1, which is 6. Okay? So that's kind of where it comes from. I think it's important to visualize this first before we get into some huge questions, like this one. Brittany has 55 songs in her, what kind of phone you got? Samsung. Galaxy? Okay. So if I said to you, this would be yesterday's question, how many different ways could she arrange to play those 55 songs? Right? I could choose the 10th one first, and the 23rd one second, and the 55th one third, and so on and so on. There's lots of choices here, isn't there? Like 55 factorial choices? That would be a pretty big number. But today's question says she wants to choose, actually that's not a good word, arrange just 5 of them for Brad. How many ways can she do this? So she wants to arrange 5 of her 55 songs. Okay? So common sense says, well, to pick the first song, how many choices does she have? Yeah. If this is ice cream, guys, and I want a 5-scoop ice cream, and there's 55 flavors, I mean, if I just want a 1 scoop, how many choices do you have? You got 55 choices, right? So 55, and then to take your next song, I can't duplicate the same song, okay? Not yet. I got 54 choices left. Okay, so 55 times 54. The third song, now I got 53 choices times 52, okay? But that's the common sense. Let's use our formula. I got n items, 55. I want to arrange 5 of them. That's equal to n factorial. N is 55. Okay, but I'm not choosing all 55 songs. I only want 5 of them. That means I got to subtract, or I might got to cancel on the bottom everything under 49 factorial, right? So how do I do that? I go 55 minus 5, actually 50, factorial. Okay? But don't put that in your calculator. Let's simplify it first. So that's 55 times 54 times 53 times 52 times 51 times 50, so on and so on, all the way down to 321, right? That's on the top. What do I have on the bottom? 50 factorial, which is 50 times 49, all the way down to 3, 2, 1. Can I cancel some stuff here? Yeah. Okay, 50 divided by 50, 49 divided by 49, all the way down, all this stuff cancels out. So like I said, the common sense way says, I got 55 choices for the first song, I got 54 for the second, times 53 times 52 times 51, okay? So that you can put in your calculator. Quickly, let's just visualize this thing. And that's a lot. Would you want to draw that picture? Yeah. You'd be here until you were my age, perhaps longer. Perhaps you would never complete it. 1, 2, 3, 4, 5, 417,451,320 choices. That's how many ways it is possible to choose 5 songs on her Samsung phone if she only has 55. What if she had 300? Yeah, I don't even know if the calculator goes that big. Well, yes, it does. Okay? Now, is there another way to put that in our calculator? What if this is taking us along? What if I got 20 things to multiply here? Let me show you how we're going to do that. We're going to go 55, math, probability. You see what we're doing today? What's NPR? Hey, does that look familiar? Enter. You got to put the first number in first for N, then the second number in for R. That's how it's going to look. Same number. Okay? So, what does NPR mean again? I'm arranging R items from a possible N. How many permutations can I get? Okay? That's what that says. A lot. Okay, so I'll just write here, use NPR function on TI B. Let's add one little level of complexity to this. In other words, let's make it a little more complicated. She chose one song in particular that's got to go first, right? That's like the wedding song. Like, that's the song, okay? The other 4 don't really matter. Did you guys choose a song yet? Oh, big meeting. There's going to be fights going on. One song goes first. That's it. Now, how many choices are there? How many arrangements are there now? Well, what does common sense say? You've already chosen one song. You got to choose 4 more out of how many? Now you're down to 54. You've chosen that one, so you're not going to play the same song twice, right? Everyone will go, what the hell? This is ridiculous. Worst grad I've ever had. Yes, I'm going to have to grad again next year just so I get a new song. All right, so you might just rethink to yourself, that's just a new problem. I'm going to ignore this song. I got 4 more songs to choose out of 54. You know how to put that in your calculator? Yeah. But the proper way to actually do this is you're going to choose one song, that's going to be your choice, and then you're going to multiply it by, well, I got 50 more and I'm going to choose 4 of them. Okay? That's as complicated as we're going to get today. So 1 factorial over 1 minus 1 factorial times 54 factorial over, so you still need to kind of know this method, okay? Not just putting it in your calculator. Because 54 minus 4 factorial, what's the first thing become? What's 1 minus 1? So what does 0 factorial mean? How would I put that in my calculator? How many ways can you choose a 0? Yeah. Okay? It's a bit of a significant meaning. So if you see that, you got to remember this, okay? 0 factorial is 1. And again, this is something, you know, professors in math have figured out long ago. And, you know, can you take the square root of -1? They rethought about it, took them 10 years, they came up with an answer that, yeah, it kind of does make sense to take the square root of a negative number. We're going to call it imaginary. Okay, it makes sense to say 0 factorial is 1. Okay, how many ways can you choose a 0 after all? Okay, so I'm not going to get into the argument, but you got to know that. Okay, so essentially 1 factorial, we're just multiplying this by that. So do we really even need this? No, it doesn't really affect our outcome. Okay, but properly that's how we do this. There's going to be other questions where that's not going to be a 1, it's going to matter, and you need to multiply them together. Okay, so, but this one, we know how to do that. 54, probability, number 2, choose 4 of them. Okay, now she's down to 7 million choices. Yeah. 7, 5, 9, I don't know, whatever. 7, approximately 7 million choices. 7 times 10 to the 6. Okay. So last little tidbit. Oh, I'm not at the end of my page. Gotta get in the way. Arrange 4 of 4. Let's call it items this time, not objects. Okay, let's use our new formula. Is this something new, or did we do this yesterday? Yeah, it's all I'm saying is arrange 4 items, because we didn't know that you could arrange less than 4. So if I'm arranging 4 of 4, how would I do that? If this is a 4-letter word and I'm arranging all 4, right? I have 4 choices for the first one. I have 3 choices for the second one. I got 2 choices for the third one. And the last one, it's only got 1 place to go. And we would write that as 4 factorial. So this should be the same thing, right? So use your formula. Okay, well, n is 4, and r is also 4. So there again, we get 0 factorial on the bottom, which essentially means I'm just dividing it by 1. It's just 4 factorial. It's the same thing, right? So, I mean, it's got to still work. Right? We did it yesterday. We can't tell you, oh, everything yesterday was wrong. Now here's the new way. Okay? The same thing. Okay, so I'll reinforce this stuff again tomorrow. Like, this is one of the things where if you just do today's stuff, it's okay. If you just do tomorrow's stuff, it's okay. And the days before, oh, that was fine. I breezed through it. But when we mix them all together on a test, you're going to look at the stuff and go, okay, which one's which, right? So tomorrow we'll look at that again, all these problems mixed. Try to sort out the difference, and then quiz on Friday. That's halfway through the chapter.